Good morning, students. Today we will take up a very important topic from the atomic structure, that is finding the of electron for hydrogen and hydrogen-like species. So students, in exam the calculation involving the energy of electrons for hydrogen and hydrogen-like species are asked in different units. So we have to know the formulas in different units. Okay. So let's derive the formulas and I will tell you the formulas. So first I will write the Rydberg formula, students. Rydberg, Rydberg formula. Which is given by 1 by lambda is equal to 109,677 centimeter inverse 1 by n1 square minus 1 by n2 square. Students, this is a formula which is used in atomic spectra, okay, for finding the spectrum of hydrogen. So from this formula we will find out the energies. Okay, so let's derive this. So first I will convert this centimeter inverse to meter inverse. So I'll get 1.09677 into 10 to the power 7 meter inverse 1 minus n1 square minus 1 by n2 square. After this, students, I'll put, this is 1 by lambda, I'll put high C in both numerator and denominator. So here, this is high C by lambda, so I can replace this high C by lambda by E. Okay, we know that from Planck quantum theory, E equal to h mu frequency and E equal to high C by lambda. Okay, so I'll write here delta E and I will move this h and C on this side. So 1.09677 meter inverse into 6.626 into 10 to the power minus 34 joule second into C, the value is 3 into 10 to the power 8 meter second inverse 1 minus n1 square minus 1 by n2 square. So I will cut meter inverse, meter second inverse, second. So the only unit left is joule. So delta E is equal to, so students, after calculating all these values, I will get 21.8 into 10 to the power 19 minus 19 1 by n1 square minus 1 by n2 square. Delta E is equal to 2.18 into 10 to the power minus 18 1 by n1 square minus 1 by n2 square. So this is the formula in, students, joule. Okay, joule per atom. So let's change this formula to the energy of electrons for hydrogen and hydrogen-like species. Okay, so I'll change this delta E to E and I'll put a negative sign showing the energy of electrons 2.18 into 10 to the power minus 18, and I'll replace this by Z square by N square, where Z is the atomic number, N is the principal quantum number representing the energy level where the electron belongs. And this formula is in joules per atoms. Okay, so this is the first formula you have to note. So when it is asked in joule per atom, you have to use this formula. So next, students, I will express this in another form. So here, let's express this in joule per mole. Okay, so for 1 mole per mole, students, we have to multiply this value by Avogadro number. So minus 2.18 into 10 to the power 18 into 6.022 into 10 to the power 23 Z square by N square. So students, here I will get the formula in joule per mole. Okay, so when it is asked in joule per mole, you have to apply this formula. So the value comes out to be minus 1.312 into 10 to the power 6 Z square by N square joules per mole. Okay, So here you have to note another formula, okay, in joule per mole. So you see the difference in the values, okay. Here minus 2.18 into 10 to the power minus 18, and here minus 1.32 into 10 to the power 6. It is joule per mole and it is joule per atoms. After this, students, we will take up again electron volt, okay. So it is also important, electron volt. So let's convert this energy formula in terms of electron volt, okay. So for this, we have to know that 1 electron volt is equal to 1.6 into 10 to the power minus 19 coulomb, okay. Joules, sorry, joules. So let's convert this. For this, I will use this step, okay. So I will again replace this value here, or we can also calculate from here also, okay. So here let's start from this again. So E is equal to minus 2.18 into 10 to the power minus 18 z square by n square. So students, here this is in terms of joule per atoms. So I will arrange this into 10 to the power 19. So 21.8 into 10 to the power minus 19 z square by n square, and you see 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. So for 1 joule means we have to divide it. So divided by 1.6 into 10 to the power minus 19. Here the answer will be in electron volt, okay. So what you will get is energy is equal to minus 13.6 z square by n square electron volt, okay. So this is the formula. The last formula is, students, the energy of electron in electron volt, okay. So these are the 3 important formulas for finding the energy for hydrogen in hydrogen-like species, okay, that is which contains only 1 electron. So students, in exam the questions asked from this also, this also, this also. So we have to identify whether the given unit is in joule per atom or joule per mole, or it is in electron volt, okay. So you have to remember these 3 formulas very clearly along with the values, okay. To minus 2.18, minus 1.312, and the last one is minus 13.6, okay. So all these formulas can be derived from this Rydberg formula, okay. That is the spectra, the atomic spectra portion, okay. That is it. Also clearly denote the relationship between the Bohr atomic model and the atomic spectra, okay. So I hope you will note these important formulas and the steps how these formulas have come, okay. So I hope the video is useful to you guys. So we'll meet with you in the next time with some other new important topics, okay. Bye, students.